Welcome, Andrew.
Hi. If you don't know who I am, you lucky people, I'm Andrew Jeavons, and I don't think this will be as interesting as the last talk, but I'll try to make it that way. I'm going to talk about these things called RAGs. One of the worst acronyms I've come across. And it's not to be confused with Ragtime music, which if you download the presentation, you can click on the button down there and it'll play you some Scott Joplin. And it was a very interesting chat. Talk about what RAG's supposed to be, the core concepts, and it's got a lot of things to do with vectors. And as it's ASC, I'm going to put a very limited amount of numbers on the screen, so don't get frightened. And then talk a bit about how this is to do with LLMs, AI, and then the issues of implementing these things, which there are a few questions, and then try and do a live demo, and buggers who want me to fail, of which I know there are several. What problems do these RAG systems solve in theory? We're getting very good at generating lots of reports, and particularly now that we have all these AI tools, we can generate lots and lots of reports. I mean, we did a project recently, and most of it was, including the report at the end, was AI generated. We didn't touch it. There was a nice big PDF at the end, and that was great. But we're churning these things out at a fantastic rate. So the guy who invented this stuff, I think originally it was that he wanted to talk to some PDF. Most people want to talk to other people, but hey, whatever floats your boat. And this is a way of interrogating this amount of text data, essentially, and being able to ask it questions and get sort of reasonable answers back. And he came up with this very interesting solution. I asked DALL-E to produce a surrealist image of, mounds and mounds of paper. And he came back with this image. And if you look here, there's a weird bird-like creature, the like of which I've never seen. And that was its idea of a surreal image of overload with paper. So, way AI. What is a RAG? This guy called Patrick Lewis, 2020, came up with the idea. Retrieval Augmented Generation. To me, the acronym seems malformed. Shouldn't it be a Retrieval Augmented Generation? Just sort it out. The idea is that you're taking text, PDF, ordinary text, document files, Excel files, CSVs. I think there's a library out there that will take in 100 different sorts of documents, which I didn't know they existed, and render it into a form that you can use it in a RAG. There are two companies, if you're interested. One's called LangChain, the other's called Llama Index, and they are churning out a furious amount of information and tools and videos. I just saw there's a 2.5 introduction video from LangChain on YouTube, so if you want to learn about this stuff, there's an awful lot out there, because it's actually becoming, quite common and very useful. The other major component of this is this thing called a vector database, and I'll talk about those in a minute. And they are a way of accessing textual items and searching and looking for semantic similarities. They're very clever. And a couple of examples, a few of those, a company called Pinecone, Milvus, Qdrant. There are a bunch more. I discovered a new one yesterday. There are lots and lots of these. You get to choose between things like totally web hosted, which is Pinecone, or stuff you can run on your own, which is Qdrant. We use Qdrant just because, I don't know, I picked it a while ago and it seems to do what it needs to do. So that's pretty useful. The last part is some sort of LLM/AI. So, pick your poison. GPT-4o, Claude Opus, and our experiments have shown that Claude is actually pretty much the best, we think, at summarising text and stuff like that. So it's a hot favourite. And all the llamas, which are, if you don't know, more open source databases, AIs. There are lots and lots of these, as you know. There are lots and lots of interfaces, so just pick them. I would point out that there are also a lot of there are several online vendors offering sort of instant RAGs. One that we've used is called chat-based, and it's actually not bad. So if you don't want to do any programming, you can use those. Vectors, two central concepts. Rendering text, any piece of text, as a vector, a fancy name for a list of numbers. That means that similar pieces of text produce similar vectors. And that's quite important. You know, you techie people all know about things called hash codes and all this kind of stuff. And there have always been algorithms that will take text and turn them into unique numbers. But they won't, if you have two similar pieces of text, turn them into very similar numbers. Indeed, some of them rely on that, property. But these processes, and we'll get into them, usually they call them embeddings for obscure reasons, take pieces of text and they turn them into a list of numbers so that different pieces of text, or that may be semantically similar, produce similar vectors. So you're encoding them in a way where you'll preserve semantic information, and that's really the core of this stuff. And then these vector databases do a thing called nearest neighbour analysis. So you can go and look that up. It's called k-nearest neighbours. There are other algorithms as well, and they're getting very fancy. So it means that when you say to it, show me a piece of text that's similar to this text, it'll show you the piece of text that is semantically similar, which is pretty cool. And actually is the core of these kinds of systems. It's not so much the AI at the other end that I think is really, frankly, the remarkable thing. It's these vector databases. And this stuff all goes back, if you're really interested, to 2013 and a guy called Mikolov who invented or sort of developed a new form of this thing called word-to-vec, which means you took words and you generated vectors, numbers. So similar words have similar vectors. If you go and read about that stuff, it kind of kicked off a lot of the wave of AI that we have now. So, there you go. This is an example. And it's really fascinating, isn't it? So here, the cat sat on the mat. It is the ASC. Rebecca said to me, you can put numbers up, it's okay, it's the ASC. The dog sat on the mat. Now, I didn't actually plot them. I'm hoping those two are sort of similar. And then colourless green ideas sleeping furiously. Anybody know who said that? Yeah, it's this dude called Noam Chomsky. It's about linguistics. It's an example of a sentence that has surface structure, it's grammatically correct, but no deep structure, i.e. it doesn't mean anything. The other two do mean something. And this is just the core of these systems, is that you can take these pieces of text and get vectors, numbers, and there will be similarities. And you compare these vectors in the various ways. The most common way is called cosine similarity. It kind of renders it into this geometric solution. Don't ask me to explain it. I did understand it years ago, but it kind of went away, like so many other things. If you're interested, this is using something called Hugging Face, which is a massive site of all sorts of AI models, these embedding models, vast resource. And you can download this transformer and use it. And this makes vectors that are 384 numbers long. OpenAI, a little while back, launched a embedding that gives you 2,000 numbers. And it's a question of whether or not more is good. Because, you take more time if you try and, render things into longer sets of number. It makes your database bigger. Is it making your database better? There is research being done on this, obviously, but it's a question. Is more numbers bigger? If you take a sentence that's 50 characters long and you turn it into 2,000 characters, 2,000 numbers on a vector, is there an issue with noise? I don't know the answer to that so far. Okay, so let's say you've got your PDF. And it's a report, and it's talking about various different things that you're trying to tell people. You want to divide that into bits of text that you're then going to render into a vector. The question is, how do you divide the report up? Do you take every sentence in the report and turn it into a vector? Do you I don't know, look for sections of the text that is semantically similar, that's talking about the same subject, and make that into a vector? Do you just say, well, I'm going to take the first 300 characters, that's going to be a vector? Nobody really has come up with a good answer to this. I mean, if you've got open ends, and if I do this demo, if it works, it's open ends from, unfortunately, a survey about Brexit, but it's fairly obviously there how you divide it. You take each open end, you turn it into a vector. I mean, there's no point in chunking things together from different respondents. It doesn't help you. Sure, that's clear. If you've got something like a PDF, well, to take all the sentences, you could. That's going to give you quite a big database, but space may not be an issue. These days, space is really cheap. It may add an overload to the processing time because of the database program that's going to process these things. Are you better off doing the N-word chunk thing? You take, 300 characters and you just chunk every document into 300 or 400 or 500, whatever it is. I mean, there's some project floating around about an airport that I can't talk about, but it's about 380 PDF documents that they want to put into one of these things, and they want to be able to ask it questions about policy. Well, how do I chunk those up? It is a difficult issue. I even saw something where they're saying that, okay, if you do this N-word chunking, you take, let's say, 500 characters. The first and last 100 characters should overlap with the previous chunk. So you're doing it slightly overlapping chunks because that helps with context. I'm not even sure I believe that. And I haven't seen anything that proves it's better. So again, this is a bit fairly typical of the AI world in that it's a bit Wild Westish. I mean, there's a lot of stuff we don't understand. And of course, these systems, these embeddings that turn the text into vectors are constantly being developed. Like I say, OpenAI just launched one that's 2,000 long. There are a bunch of these you can get off Hugging Face. And there is a lot of research, I think, that needs to be done to work out, given the subject matter you have, how you chunk it up and how you use it. As I said, for market research, if it's open ends, yeah, good for you. You've got a fairly clear mechanism there. But I don't know, for reports, not sure. So you add this all together. You put your text into these vectors, you've put it into your favorite database, and then you have, and we'll talk about this a little bit later and show you have a mechanism where the user says, hey, tell me, bring this up, tell me what were the main reasons for Brexit. Now, the system then takes that query and converts it into, guess what, another vector. Because it's trying to find items in the database that are semantically similar to the user query. And we'll come on to an issue about that in a bit. But that's the idea. So that it's saying, if you say something in your query, if I can find something similar in the database, we're going to say that's relevant. That could be relevant to the answer that the user has, to the question the user has. And what you actually get out of these things, and QDrank calls it a hit, but it gives you a score of the text that it thinks is close to the question that the user has. So the user's asked a question, and he says, okay, well, I think these are close. And it gives you a value. So who've got hit 0.67 and hit. Basically, I've said anything over a 0.5, because the scale is 0 to 1, is relevant. It's fairly arbitrary. I mean, obviously, if you change that value so you only want things that are really, really relevant, you might get better quality responses, but you might lose something in that the broadness of the answer is lacking. Again, this is one of the things that you have to tune in these things. It is an area where experience counts for a lot, and experimentation is going to be quite important. And what we got from that, eventually, which we'll talk about in a minute, is, hey, the main reason Brexit summed up for sovereignty, immigration, blah, 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 all this kind of stuff. How do we get that? Well, what happens once you've got these database responses is you bundle that up with a suitable prompt for one of your favourite AI, saying something like, here is the responses to a question, blah. Summarise these and convert these into something that's readable. Basically, summarise. One thing, as you probably all know, that the AIs are pretty good at is summarisation. We find them extremely useful for some of the stuff we do on text topic analysis and all that kind of stuff. Very good for summarising stuff and saying, yeah, this is the core of it, these are the arguments. And that's what you get back. And this is the idea of these systems, that you can take a load of documents, process them, and then ask questions about them. And the users love this stuff. We had one from a very big food company, which was a bunch of recipes. And so we put this into a RAG. And they sit there and go, oh, tell me a recipe for rabbits that involves mustard. Or something really, we looked at some of the queries, so it's all pretty weird. And it goes through and it finds out based on these other recipes that it's found, and it'll make up a recipe or show them a recipe. And it's, hours of fun. I mean, the great thing is you can set these things off and go charge the clients to answer their own questions. That's got to be that. So that's the core of the idea. Yeah, I mean, as I say about the always pick your poison, Anybody ever heard of this thing Grok, G-O-Q? This is not Musk's AI. This is a bunch of people have got together and they've made these really fast bits of hardware, really, really fast, and I think they've got Llama 3 on it. And it is incredibly fast, and it's not very expensive either. And so it's worth considering when you're looking at this stuff. I hope they last a long time. Apparently they've built and designed their own chips to do this kind of stuff. But it's amazingly fast for a lot of information when you send down. So, the issues of speed and accuracy in inverted commas, it's a big question. What kind of guardrails? That is, you can send, as you probably know, you can send these AIs information or ask it questions, and it doesn't like it sometimes. We currently have a problem where we ask GPT to generate an image prompt, saying, we want to make an image embodying executive at topic analysis, embodying the topic. So we say, write a suitable prompt for DALL-E 3 that would generate an image that would embody this topic's content. And it'll write you a prompt. You then send it to DALL-E 3 and it says that violates our rules. So you then say, write a top prompt that doesn't violate, DALL-E 3 rules and all this stuff. You then send it and it says the same thing. I mean, I don't know how to get out of that loop at the moment. Anybody got any suggestions? I'm glad to see it. So this is the core concepts. There's a link down there because I actually stole this image. And they're very useful. As I said, the biggest decisions are about the vector DB, which one you use, and the AI that you use. As I said, we found Claude is pretty good at summarization. We may switch over from that from GPT-O, we'll see. And this is an example which maybe I'll be able to run. You go in, what would you like to know? What are the main reasons for Brexit? And potentially the user can download this, all this kind of stuff. I don't know if you realise this, but you need to put limits on the amount of back and forth you have with the AI, because you actually are sending up a lot of information back and forth to the AI, and it can get quite expensive if you're not careful. The issues, the questions you've got to answer. Query optimization is an important one. How clear is the question from the user? You can imagine that a user might generate something quite obscure or write in an obscure way that may not be very clear to the vector database in a sense of what it's trying to match. there are there's a lot of tools, and there's one tool you can get out there that'll say, okay, this is what the user asked. Generate a suitable or several suitable queries for a database of text that would provide information that would answer this question. So it's really trying to optimize the query before you put it to the vector database, which I think is probably one of the most important optimizations that you can make on these systems, because I think it's very easy for people to write, long rambling questions, which then obscure what the semantic context of the query is, which then the vector database really can't sort out. There is a lot of work being done on this. There's also modules you can get which, convert your query to an SQL statement that'll go and retrieve the data. One other thing you can do with these databases, and I'm pretty sure you can do it with all of them, is you can attach what the database I use, Quadrant, calls metadata. So you have a piece of data like, the text was the cat sat on the mat, the vector's there, the vector of numbers. Then a bunch of properties like, the cat was 8 years old, it was a black cat, and all that kind of stuff. And you can potentially include that metadata, which was attached to the text, in the information you send to the AI, if that makes any sense. So that it's not just the text that goes up to the AI. The text goes up to the AI, but it also says, hey, it was a black cat, it was 8 years old, it had just been fed or something like that. And it'll use that information to generate the answer. And potentially, and this is where it gets interesting, the query that the user gives could be something like, well, looking at black cats, why did they sit on the mat? Things like this. So the idea being that you can use this metadata that's attached to the text in the query, and there are filtering mechanisms for that. But that's getting really complicated. I haven't done that yet, so I don't really know about it. The system prompt, as any of you who've used the AIs will know, is pretty important. We've got some mutant rags that combine things like, take on the opinions and attitudes of Gen Z population, and you tell them something about that and use that to filter the answer. You can get quite fancy with that. But again, worth experimenting with. Now, I'm going to try and do a demo, and I may regret this.
Just show password for it.
Whilst Andrew's getting in there, has anyone got questions for him?
I have a question.
I have a question as well.
Okay, fire away.
Why,
multitask.
why
Honest.
do you go to all the bother of all that vectorization stuff? Why can't you just take your, let's take verbatims, give your favourite GPT, your 1,000 verbatims, and say, tell me everything that talks about colour.
Yeah.
And because it knows that red, you can. So what do you get better data if you go through that whole vectorization thing?
Cost.
Why would you do that?
Part of it is cost. And I've done this. You can take, your open ends and shove them up to GPT and ask it to do things with them. But at a certain point, it gets quite expensive.
Okay.
As we know, the input context of the AIs went from quite small to quite massive.
Big, yeah.
But it doesn't cost any. It costs money, although GPT has still just kind of halved the cost. And there's a performance hit.
Okay.
It can take quite a while. And these days, 1,000 open ends, but we've got, I think it's 300 PDFs for this airport thing. That's just too much to be sending up and asking every time, asking GPT to mess around with it.
Okay.
I suspect, and some people have debated this, as the context windows have got bigger, you can put more stuff up. But then people are saying, well, we can then use 3,000 reports. Let's take the last 10 years, all the reports we've ever generated for anything, and put them into a RAG. So you've got a point.
Okay.
Any other? What's the next question?
The other question is this: vector database, you get lots of numbers, you don't know what any of them means.
Not really,
You know,
no.
you can, find a proximity between text, by using whatever distance. Would it make sense if you got all of your response to an open-ended, to do after that the principal component analysis?
Yeah, it would.
Okay, and then understand what are
Yeah,
the meaning
definitely.
of the underlying factors?
Oh, definitely. Yeah, I think there's a lot of room for that kind of post-processing for then saying, oh, look, the vectors do all these answers for this. What are the commonalities between them? Can we cluster them? These vectors are great for clustering text.
Yeah.
There's a technique called BERT, B-E-R-T, which essentially is, you take a bunch of text, you vectorize it, and I've done this, then you do something like k-means on it, and then you've got clusters. Well, the only issue, it's not an issue, it's solvable, is that, it's great when you've got 10,000 text items. When you've got 50,000, 100,000, 500,000, you've got to start doing some fancy AWS stuff, which I don't like doing. My solution to it was to buy a really big machine with a lot of memory. And I can do about 100,000 items of text and do a k-means clustering on it. But yeah, it's actually a very useful technique. So this did actually show a result for nationalism. Okay, I have no political statement to make here. This was just the only data I had. And then you can say, what? No, you can't. What about pets? And it sort of thinks, it found some text there, which I was a bit surprised. I hadn't looked at this. It thinks it found something. Oh, nice. Well, good. It didn't. It's an irrelevant question. It couldn't find anything that matched that talked about pets.
Pets in the context of why we did Brexit.
Yeah, I think that was the question, what were the reasons? I don't understand get that, so...
Not to get reading.
Sorry?
Not to get
Keep
reading.
up the screen. Keep up the screen.
Yeah.
So we'll wrap up in a sec, Andrew.
Okay, sure. Right, I'm trying to find something that was actually... I know which one it is, which is deeply relevant, which people won't like, but this is one.
Age.
There wasn't, I did look at age actually, there wasn't anything. Now, this, yeah. And it definitely starts puking out some stuff here.
It's got lots to say about that.
So, summary of these things, they're actually really useful. There is a lot of information out there about them. There are a lot of people working on them. As I said, LangChain and Llama Index are the ones that are doing the most. And thanks for listening.